Um, I see a hand up. Is there a question? All right, well, let's go ahead and get started then. Welcome, everyone. Good afternoon, and welcome to the inaugural AI plus Education Learning Community Series. I'm Suzanne Rosenblith, the Dean of the Graduate School of Education here at UB. This set of monthly collaborative learning opportunities was designed to help educators, school administrators, and university faculty learn collectively about the power and potential of AI for learning and for research. I'm so excited that we have so many people with us today, and I look forward to the generative conversations that emerge from this collaboration. We often talk about silos between higher education and K-12, and I think that this series really has the potential to demonstrate the power of working and learning together collectively. I want to thank in advance all of the facilitators for sharing their time, expertise, insight, and questions with us over this year. And then finally, I would like to extend my sincere gratitude to Dr. Christine Wang, Professor and Associate Dean for Research in the Graduate School of Education, who has just done an absolutely amazing job with all of her other jobs and responsibilities pulling this together. So this is our first of 12 installations, and we are fortunate to be joined by Jinjun Chiang, Director of UB's AI Institute for Exceptional Education, and Brian Graham, Superintendent of Grand Island Schools. So Jinjun and Brian, I'll turn it over to you.
Hey, thank you, Suzanne. And let me just start to share the screen. And okay, are you able to see the screen, everyone?
Yes.
Great. Okay. Welcome, everyone. Thank you for joining. And as Suzanne mentioned, and this is a very important topic, and at the UB, and so we are fortunate enough to be the first one to kick off this conversation. And feel free to leave your messages in the chat box, in the chat window. And if you have any questions, or if something you want to interrupt, feel free to just pin Christine if you want to interrupt. Okay, and we can have the conversation along the way. And to get it going, and my name is Jinjun Xiang, and I'm the Empower Innovation Professor and at the Computer Science and Engineering Department, and at the UB. And together with me is Dr. Brian Graham, and the Superintendent from the Grand Island Central School District. And so we will follow the abstract that you saw. And so in today's conversation, I will talk about the modern AI. Is it finally here for the social good? That's kind of the title we throw together here. And essentially, this conversation, we will give you some of the high-level intro of what is the modern AI, like artificial intelligence, and a little bit of a historical perspective, and also give you some very fundamental concepts. So that way, everyone will be comfortable to talk about artificial intelligence. And you should be very comfortable to read the articles, right, and pick up those terminologies, and especially from the news articles, etc. And afterwards, we will talk about a few use cases, and in particular, use cases at our National AI Institute for Exceptional Education, and led by UB, and and we'll also show you some of the potential demos, like screenshots, so you can see how the AI can be used and to solve some of the real cases. And so we will then open up and for some questions and discussions. And we'd really like to get your inputs and comments about some of our work and some of the use cases that you may bring up as well. And so I assume some of you may already kind of read the articles we recommended offline, right? And so some of the readings, and if not, I feel it's okay too, and along the way, we will touch upon some of those points as well. And let's just get started, okay? And in the title, I mentioned the modern AI, and really meant, okay, the AI, as you can see, for some of you maybe think AI, artificial intelligence is something new because of suddenly have so many people talking about it, right? But I want to let you know, actually, it is not the case. And artificial intelligence is a technology, like any technology, right? This is very interesting. This is called Ghana's hypercycle for the new technology, which means that the technology at the beginning, right, like innovation just the beginning, and it pick up the public's interest, and it was started to kind of ramp up, and the very high expectation. And after some time, and people start to get to know more about this technology, right? And this is knows the expectation may be inflated, and this is kind of come to realization, and this is kind of dropping down the expectation, and this is called the trough of the disillusionment, right? And once you are done, but you still realize actually this technology has some value, and then through the second kind of emergence of the technology, and it will start to pick up the steam again. So this is a kind of a general description of any new technology, and this, of course, and artificial intelligence, called AI, and it's no exception as well. And so, in fact, actually, artificial intelligence, and from the historic perspective, has gone through this technology cycle more than one times. And in fact, it is people call it like 3 times already, right? And of course, depending on how you look at the values or expectations, and it's artificial intelligence, there's like a realization of its value, and you can go to the ground zero, or you have some kind of residues, and you pick up the steam, right? If you look at the left-hand side, and you can see the technology, artificial intelligence has been around even in the 50s, right? And it exactly shows this kind of Ghana's technology cycle, maybe the first realization, right? And it's still kind of very optimistic. It's not to go to the ground zero, and you have still have some of the popularities, but because of the job, right? People call it the AI winter, right? And then you pick up the second kind of the steams and going up, and again, the expectation get a burst again, and you have the second AI winter, and then you pick up the steam again, and a more kind of pessimistic view was, okay, this really go to the crash, go to almost ground zero, and does it seem like more appropriate for the AI winter? And indeed, we have been gone through 2 AI winters, and the current AI, like now, the one you are seeing right now, right, and where we are today, and in fact, it's the third kind of rebirth of the artificial intelligence, and that is called the modern AI. And of course, along the way, there's multiple events happened, and why people in the first AI kind of the period, right, have this high expectation, and why this expectation was not able to be delivered, and how does the second systems, like based on the expert systems, and come back again, and rule-based systems comes to be another promising direction, but at the end, and still because of some of the short back, kind of and the shortages of the expert systems, and it crashed again, and the modern AI and seems like it would be very promising, and this is where we are now. So this is a very quick summary of the historical perspective. So now let's talk about the modern AI. What made this modern AI possible, right? And what are the moments made the AI and possible? So to speak up this one, I want to just go back to a few years. It's not far away. It's about 10 to 15 years, and this is the event, led by IBM, and called the Jeopardy. So I assume most of the people here knows what Jeopardy is, and so IBM decided to invent a machine, right, and to participate in the Jeopardy, and competed 2 of the best champions in the human being in the history, and to see, can AI, right, or can machines to compete with human champions? And here, just give a quick examples to show you, right? This is one of the questions from the Jeopardy show, right? And from the very top, give you the question, some kind of the context of this question, right? An American quiz show since 1964, and it's a little bit, it's kind of like a question and answer. It's kind of a little bit flip the format, right? And the contestant will give this presented the cues in the form of the answers, and the contestant must phrase their response in question form. For example, if the contestant choose the question categories like a general science, and the display will show you, hey, what this is a clue, right? Like when hit by the electrons, a phosphor gives off electromagnetic energy in this form. So now, as a contestant, you have to find the and this is kind of answers. Or sometimes maybe you give a different clue, like this number, one of the first 20, use only one vowels and 4 times. And what would be the kind of the question, right? And so, as you can see, this question is not a simple kind of a question answer, right? It's a little bit of need some thinking and understanding the phrases and understanding the natural languages. And this is the correct answer. The first answer is what is light. The second is what is 17. And here, of course, I gave some very simple illustration. And the real shows is much more complicated in the background shows, right? And you have for each category, you have to pick which category you want to answer to get the answer, get the question, and also what is your betting strategies. And at the end, it's the accumulation and to decide are you going to win or not. And as you can see, this is a very complicated game. And the long story short, right? In 2011, and IBM invented this machine called Watson, and on the air, the TV, right? And it showed the IBM Watson machine and defeated the world champions of the final Jeopardy. And so that's really kind of the wake up moment. And here I'm just highlighting a few kind of key facts, right? Why IBM's technology at that time, right, was able to win this game, and why it made a difference. And the first one is there's a whole solution. It's a data-driven approach. And rather than the previous AI is a rule-based, like an expert system. So the data-driven approach is more robust, and the rule-based system is typically very brittle, and which means it's not easily generalizable to new situations. And that is the first one. The second one is, the modern AI demonstrated much more advancement in terms of natural language understanding. And as the question illustrated, natural language understanding means, okay, the natural language is unstructured. And if you are able to understand the unstructured natural languages and participate in this kind of the contest, and that's going to bring the AI technology into the next level. The third fact is this human-like reasoning, right? As the show kind of the competition showed. And not only about, this is not a simple fact finding kind of the question answer, right? It requires understanding the question and also with reasoning and also with betting strategies, because there's a rewards and the penalties goes along with it. So you need to have the good reasoning capabilities. And of course, because you need to handle the data and the whole system need to be off the internet, right? So which means the computation at its end is that you need to be realized all of this. So the bigger computation and deal with the bigger data. So this I can think of the high level, the 4 factors, you can think of because of the modern technology development, and that has become like a breaker point, and that really makes a new period of the AI and picking up the themes and generate a lot of interest. And fast forward, right, since that moment, February 16th, 2011, and a lot of things happened, right? And for example, like 5 years later in 2016, this is another very exciting moment in the AI, modern AI. And Google's invented another machine called AlphaGo, and that defeated the Go Grandmaster Lisa Doe. And the Go game is considered one of the holy grail in terms of the complexity of any games with clearly defined rules. And this is another kind of very exciting moment to show. And the modern AI now is able to win the humans in this most complex games ever. And another kind of faster forward, 4 years later, right, in 2020, and that's another kind of very exciting findings. And again, by the Google's DeepMind, and it's the AlphaFold, right? And AlphaFold 2 and it solved basically a 50-year-old kind of grand challenge in the biology. That is related to drug discoveries and the medicines. And so all of this kind of findings, right? Maybe some people here is young enough, maybe didn't realize it. Like the IBM said, the Watson machines, and this is kind of very science kind of driven, right? Kind of findings. And I think, but modern days, people knows about AI. It's because another very recent kind of breakthrough in artificial intelligence, which is now it's about a little bit more than a year ago, right? And that is ChatGPT, and November 30th, 2022, when the OpenAI released the ChatGPT, and really I would consider that is the latest breakthrough. Right now, almost everyone knows about AI, and the common street people knows about AI, talk about AI, is because of the ChatGPT, and because of it's simple to use, right? And the messages are so clear, and people immediately kind of experienced how AI is going to touch everyone's life, and how AI is going to change everyone's interaction with computers. And that is why people start to really kind of raise the high expectation about AI now. And that is why today, so many people join today's conversation, right? It's about AI. And I think it's AI, ChatGPT really made a difference here. So this is kind of the few key historical moment, right? So now I'm going to switch this gear to the next topic, right? What is AI anyway? And especially, and I'm sure you read the articles, right? Sometimes you hear some other terminologies, like for example, machine learning and data mining, and you may be wondering, right? And are they the same thing, or are they different? And why people use it seem like this phrase is kind of interchangeable. Sometimes use AI, sometimes use machine learning, and why? So I'm going to demystify and all of this for you, okay? And a few very simple kind of slides. And so I think you already kind of knows the historical perspective of AI, artificial intelligence. But when we try to defining the artificial intelligence, I think everyone seems like have some kind of high-level intuitive on this kind of definition, right? Because artificial intelligence means you want to have some intelligence, like human intelligence, exhibited by the machines, because that's what we call artificial. It's not the human. And here, when we say the machines, and in the world of computing, right, it's very, very specific. It's not the mechanical machines or anything. It's the computer, right? It's the computer program, more specifically. So which means the computer program can somehow exhibit human's intelligence. That's called artificial intelligence. So what is machine learning? So the machine learning is something like I give a little bit of a more descriptive definition here, and just kind of follow my descriptions here, right? Again, machine learning is still a computer program, but because in order to talk about the learning, right, now it's kind of similar like humans, talk about the learning, which means you have to define a metric, right? So which means you define a metric, like in this case, I call the P here, for example. Okay, forget about the alphabet. Okay, just think of it. You need a metric, and then you give a task, right? And you also need to give it some kind of a bunch of the things you need to learn, right? Called experience. And if this computer program measured by your performance after this experience, and the performance getting better, which means this computer learned something, right? So this is kind of like a human, you did some homework, and you did a lot of homework. That's your experience, and your kind of the metric is your final, like a score, right? If after the homework, your final score getting better, means you learned something. And this is the same kind of analogy. That's the computer program. And this is called the machine learning. As you can see, right, just by simply the comparison between these two definitions, you can see artificial intelligence is a more general definition, because a human intelligence is more than a simple score, right? Having the good score doesn't mean you have intelligence, and you have a lot of other intelligence too, and the social emotional intelligence. So that's mean machine learning is a much narrower definition. And so going along, the data mining is even a kind of a narrower definition, or it's kind of a different definition. It's the process of discovering the patterns, right? It's not measured by the metric per se. It's some kind of discovery patterns through a large quantities of data automatically or semi-automatically. And that is data mining. And so you may wonder, right? So why people calling all of these terms? So this is something you can consider going back to the history, the one picture I showed you, right? The historical cycles of AI. And of course, if you really can make the first AI work, right? And that is back to the 50s, and people coined the term of AI. And that's how the AI terminology was coined. Come with the second terminology for the machine learning. And later on, machine learning has some kind of applications in different domains, right? And people start to realize the data is very important, right? So the people working on the data side start to coin their own terminology for the data mining, because the machine learning cannot dominate everything. And so the database community coined the term of data mining. So this is kind of some of the references that I put here. So if you're interested in know of the historic perspective, how the first term got coined, so you can look at those references. And also, I give you this kind of diagrams here. And again, this could be controversial, because if you look at the internet, you may find that people draw these pictures a little bit differently, the relationship also differently. But this is something like I would like you to kind of keep in mind, especially consider the historical context. The AI is the broadest definition. Machine learning is narrower one. And then data mining is even narrower compared to the machine learning. And that's sometimes, you see in the articles, you see this terminology get used interchangeably and depending on the context. And also, so in the broader sense, this AI also can be categorized in different ways. And one is called artificial general intelligence, called AGI. And this is different from the AIG, like the artificial intelligence generation. Okay, the AGI is the intelligence, right? The computer program can have that is kind of similar to the human beings. Again, this is really the first definition of artificial intelligence, and because it is so difficult to realize, and sometimes people call it a stronger AI. And but this is something that really is in the future, or maybe it's in the Hollywood movies. When you look at the Terminator, right? All of those movies, that is kind of AGI. But in practice, whatever the AI you are encountering today, and it's called the applied AI. In that sense, it's only used the programs or the softwares, right, to study or solve a particular problem. Okay. And this problem can be narrower, it can be a little bit broad, but it cannot be the general. So this will be called the applied AI, or just in contrast to the general AI, is called instead of saying strong AI, we call the weak AI. So these are some of the terminologies I hope you keep in mind, in your reading the future articles. And now let me just give you a little bit of how do we, as a computer scientist, right, and we model this a real use case, from the daily life, and how do we abstract the things, into this artificial intelligence kind of the formulations. And so in your daily life, right, like you will see a lot of things happening, right? And so we call it the physical world use cases or the process. And you have some kind of inputs, you can have some outputs, right? And in practice, we don't know what is the input, what is the output, what is the causal relationship. We just know there's a lot of things we can observe, right? And in the physical world process, and something we can observe, and something we cannot observe. And we take a subset of what we know about. And if you just want to give more kind of concrete examples, think about, like, say, this is some plant, right? And in this plant, you can do some of the, something you can measure, for example, right? And the colors, and it's the petals, and how many petals, etc. So these are the things you can measure, and you do not know which one is input, which one is output, right? And sometimes you also know, probably you do not understand why this particular plant is growing the way it is. But as human, we know, okay, this is the physical world. We can observe something. We call it observe the data. Let's say I have some problem I want to solve, right? The problem depending on your definition of the use case. So in this example, I can say, okay, I saw this plant, right? I can observe something, and all the petals and the width, and I can do the measurement, and you do a bunch of observation. Let's assume, okay, now I want to solve one problem, which is, okay, can I just simply based on the measurement of this plant, I can tell what type of plant this is. So which means that from the human, the process can be complex, but I know what the problem I want to solve. So now I can, based on my observation, which is a partial observation, right, or partial collection of the data from your daily life, right? You put this data together, become some kind of the data columns or data rows, right? And you can say, hey, based on this measurement, this is the iris particular species, right? And this one may be a different type of iris, another species. You put all this data together, and then you say, hey, can we build models? We call them machine learning models, right? And can we use the machine learning models to do the predictions, to tell me if I give you future, I give you a new plant based on this measurement, can you tell me what type of iris species are? This is how we build the models, right? And you use a subset of your observed data. By building this machine learning models, computer programs, you can predict something of interest to you. This is the machine learning process. So I would like you to kind of to think of this way, right? Because we'd like you to help formulate in your daily life, what are the problems you want to solve? What are the things you can observe, right? What are the things you like to use AI to help you? And we are here to help you to build the bridge. And one caveat is, in the physical world, right, there's always some kind of a causal relationship. But in the world of machine learning, it doesn't mean the data you collect here, even though you put as input, it doesn't mean it is the causal determination of your output. It's simply because of these associations. Okay, this is kind of some of the limitations of the machine learning. Of course, there's also new technology to try to discover some of this causal relationship as well. But in general, this cannot be guaranteed. Okay, so this is a very high-level abstract view of what is a machine learning model and how you model a physical world use cases, and it can be solved through the machine learning model or through the artificial intelligence. And this is kind of a very high-level description. And I'm going to give you more specific kind of examples. This is maybe a little bit of math, and trust me, it's very simple math, and you kind of follow along. Okay. So let's assume, right, like one thing very, very simple use case you heard of is this kind of image recognition, right? Or maybe the handwriting recognitions, and something you can you probably encounter very often, right? So here, just assume, okay, we have pictures, and we handwriting digits, right? And we want to predict what this is. And so the way we model this problem is the following, right? You take these images, you partition these images into many small pixels, right? And based on how you draw these images, and each pixel has some kind of values. And in this case, let's assume it's a black and white, or maybe some kind of grayscale, right? So now if you have a particular, let's say 504192, if a zip code, right? And for every single writing here, you can get this 28 by 28, just assuming it's some kind of the grid, right? Pixel values. And all of these values becomes your input. Let's use X as a notation. And I just means here which picture, right, you are talking about. And for each picture, and based on your the data collection we know, maybe you want to write the 5, you want to write a 04192. So you encode your information as the label, right? Like a 5 here. Let's use the position encoding. It means, okay, you have total 10 digits. Here it's like the kind of the 6th position, right? If it's starting from 0, then this is the 5, this is a 0, this is a 4, this is a 1, this is 9, this is 2. So now this is all the information you will put it to the computers. So the computers will now take this as input, take this something you want to predict, right? And build a model. And this model, let's use the functions, okay, like a f as a notation, right? So what you want to do is this a prediction of f with respect to this label, the human's expectation, we call the y, right? They want to minimize the difference, and which we call the cost. It's a function, or called the loss functions. And what we want to do, the whole AI, right, is really try to minimize the prediction cost, the loss, or called the loss functions. And among all the possible parameters in your model, and you try to find out which one can make my loss of functions and the cost to be the minimal. And that becomes my model. I'm going to use this model for prediction. This is all the math you need to know almost. And this is something that can you just you may say, okay, how did you solve it, right? This is something in this more for the complicated things, and I'll also use a very simple languages for you to understand. And I think this is very complicated. And but in the high level, you can think of this as a general optimization approach, right? And again, computers can use some very simple approach, just kind of for like what would you would do, right? In a typical case, to solve any problems, if you do not know the answers, you just take a guess first, right? You take an initial guess, you check if this is initial guess solutions, let's call it a W0 here, to see if this is good enough or not. If it's not good enough, this is not the solution you like. You just take, okay, how am I going to improve my solutions? And based on this as kind of decision, and you decide directions. We call it basically the ways to improve the current solutions. We call it direction, right? And then you take a small improvement along those directions. You get a new solutions, and then you just iterate, and until at some point you either exhausted your computation power, or you just lose your patience. You just stop, right? Or maybe the solution is good enough, and then you stop. And basically, that's kind of the high-level descriptions of what is machine learning about and how to solve the problem. And so, of course, I'm trying to simplify this ones, right? But at the high level, you can think of even the most complicated AI algorithms has some kind of flavors of this iterative improvement. And that's why you can see why you need to fit more data and why you need more computation, because this iterative compute process is it takes a lot of time, and it takes a lot of computation. And that is why you need this the data and the computation to support the AI algorithms development. And if you're some more adventurous people, right, if you want to say, hey, how do I determine which direction to go, and how do I some of the mathematical guarantees and to make it happen, right? And why do you think the real problems can be solved this way? And so you can see the real problem indeed is very complicated. There's a lots of functions. It's a multiple hyperdimension, right? And the loss of function surface is very, very kind of bumpy, right? And that's why all the computer scientists like myself and my colleagues, and we develop new algorithms and new ways of modeling these problems, and we are able to solve it. So this kind of illustrates some of the things you can see it's very complicated. And another quickly to show you how this related to so-called the artificial neural network. And this is especially some people knows about it called a deep neural network. And what it is really all about this function of f, right? And you need to have some kind of way to compute the loss function. You need to have some way to compute the final predictions, and what that function should look like. And if you from the high school, okay, I can define the functions to be a very simple linear function or the polynomial functions. But because of the complexity, the function need to be more complicated. And that's how from the computer scientists, we some of the researchers invented this called a particular structure. It's called the given name of the neural network, because it's very similar to the get some inspirations from the human's neuron, how it works. And basically take some kind of the linear combinations of the input and put the activation function, which is nonlinear functions, and you get your output. And this is only one neuron. And the interesting thing is, you put a lot of the neurons together, and then forming a neural network. It's kind of like a human's brain, right? You have a single neurons, and a lot of the neurons forming together becomes a neural network. And of course, in the mathematical sense, our neural network is only a mimic of the human's neural network, but it's not the same. But the principle is quite similar, right? Every neurons do some kind of a simple computation. You put many of the simple computations together through the network and forming some structures. And this nested functions and the complex brings you the complexity, and that can mimic some of the humans' intelligence. And here I'm only showing you kind of some network. It's a very you can think of it as only a one layer, right? Like an input with some hidden layers, and you get the output. And as you can imagine, right, we don't have to stop here. You can just continue to put more and more layers, and that is really the deep neural network, or called the DNN. And now just one more slide. I promise you, this is one more slide. It's going to go more complexity. This is something like behind what you kind of know about, right? ChatGPT, and the ChatGPT is not more fancy than what I just told you, right? In the back, it's just a more complicated neural network, and the task, right, that ChatGPT wants to do, and it's based on a model called a large language model. You will hear a lot in the news articles, also called LLM, right? Large language model. The task is also very simple. It's based on the following, right? You have many texts in the internet, right? You have many texts in novels, books. Now, what do you want to do? You want to build a model, neural network, to do a simple thing. If you have seen a particular, let's say, token or the text, right, or the character or word, let's say, for example, once you see the first word of how, you want the machine models to tell you what is the likelihood of the next word will be, right, based on reading so many articles, so many things people have written. Of course, there's many possibilities. All of the many possibilities, maybe the most likely one will be what, right? If you predict the next most likely token is R, now you know, okay, the sentence repetition becomes how R, right? Now you say, hey, I know how to predict this. The second one is R. What will be the third one? What is my prediction to be? Most likely, maybe it's U. So you will use this generation. So that's how the ChatGPT is able to generate, how are you, step by step. That's why you have to give it the context first. Once your context becomes the input, sometimes people call the prompt, right? So you give some input. Computers, ChatGPT try to predict what is the next token ChatGPT should spit out. And this is generation. And that's really is all about ChatGPT. And of course, this, again, because of the way you build the model, right, can be very complex. And that's why it shows some complexity when ChatGPT is interacting with you. Okay, so this is a quick intro about the historical aspect of AI, and hopefully give you some basic understanding of the AI, right? Some of even the math behind it. Now you can talk about it. Woo. Okay, so now I'm going to switch gear, and I'm going to turn this back to Brian, and to show you, how our society may benefit from AI, maybe in particular, right, in the educational context. And Brian?
Yeah, thank you, Junjun. And
yeah.
I may ask you to help advance the slides for me as we go through, but welcome everybody. What a great turnout, over 170 people joining us today, Junjun. And if we were in a live room, there would be thunderous applause for the slides that you presented. Because there's no way you said, oh, this is easy math, and I'm like, what? So my presentation has nothing to do with math, but I do want to introduce myself briefly. I'm Brian Graham, the superintendent of Grand Island Schools. I am so fortunate to be the superintendent of Grand Island Schools. We have an amazing team here and people who really work hard to integrate technology into the work of teachers and students all throughout our organization. I do want to let you know I was a special education teacher for 16 years. And when I was in Alden Central Schools, Tom Lyons, the principal that I worked for, was a visionary. And he asked me to work with a young man who had dyslexia at the time. This was 1997, 1998. And at that time, Tom Lyons allowed me to purchase Dragon Naturally Speaking. And I just want to touch on that for a minute. That was 1997. To look at that chart that Junjun showed with the peaks and valleys of artificial intelligence, think about what Dragon Naturally Speaking was doing in 1997 as a machine learning tool, and the benefit for veterans who lost limbs, for individuals with learning disabilities who could now express in written form their comprehension and understanding, their analysis and synthesis and evaluation of what they were reading and understanding or learning about in classes. Dragon Naturally Speaking to me was like, I was just so impressed with what that could do. And now think about what's happening on our phones right now, where we can dictate to email and other applications. I wrote one of the chapters of my dissertation by dictating to my iPhone. So the advances in computation and technology really are amazing. And so I encourage all of you who are here to, look at the work that Jinjun and Venu and Ranga are doing at UB, and also consider reading some texts that may not be assigned at UB. One text that I read this summer was AI 2041 by Kai-Fu Lee. And the reason why I wanted to start here, when the question is, how would society benefit from AI? The AI 2041 book, remember, 2041 is only 17 years away, talks about the impact of artificial intelligence for the virtuous good that it can do for society. Some things such as improving in healthcare, transportation, education, communication, improving efficiency and increasing productivity, and enabling the development of new solutions to complex problems. That is what AI 2041 and the author of that book tries to communicate. And most recently today, I looked at a study from MIT. There's a lot of literature out there that I encourage everybody to explore. So going on to the next slide, I just want to highlight the importance of the National Science Foundation. They are spending a lot of money on research, just as UB is going to be one of the leading institutes. A brand new artificial intelligence institute led by UB is funded through the National Science Foundation and the Institute for Education Sciences. $20 million to help build research that's going to focus on exceptional education, and a subset of that will be speech and language development. So it's really, really remarkable. And this slide is super important. So you can see the National AI Institute on the left there, that is UB and its partners. And on the right, it's really hard to see, but I do want to just give you a taste of what you're looking at here. There are over 20 other institutes focused on some really important problems across the United States, and all led by other universities. They're looking at cyber threats, agriculture, weather, climate, helping adult learners use AI, or using AI to help adult learners, AI to help care for aging adults. These are just some of the other institutes that received funding from the National Science Foundation. Other work that's being done is looking at how to improve agriculture through resilient agriculture, how to improve food systems and edge networks that will support the work of AI. Other institutes here will be looking at cyber infrastructure, student teaming, and molecular maker lab institutes. And I think there's even one institute that's just going to focus on AI and physics. So it's truly remarkable that this is happening, and that UB is going to be one of the leaders in this work. So the next slide, thank you. This just shows the partners that are collaborating right now with UB. I was fortunate to be invited to be on the external advisory board, and I attended a retreat in last spring with UB, and I met some incredible individuals from Stanford, Illinois, Penn State, Cornell, UTEP, Georgia Tech, University of Washington, University of Nevada, all working under the umbrella of what the vision is through Venu, Ranga, and Jinjun on developing new technologies to support speech and language therapy. So really exciting work. This is just a little bit of an example of the work that they set out to do. That when they published and applied for these grants, they identified a significant problem as it relates to delivering speech language therapy to children in need. And that problem is this simple. There are approximately 3.4 million children who have individualized education plans for speech and language development, but only 60 to 61,000 speech language therapists in the United States to provide those interventions. So the gulf, or the gap between the number of providers and the children who are in need is great. And that requires our speech language therapists to be working so hard, but also to be spending their time in group therapy as opposed to one-on-one therapy. So here's the issue. As Jinjun is showing on the slide here, right now, when a child is in need to be evaluated for speech and language therapy, it's kind of an ad hoc process, right? Mom or dad or grandma or grandpa begins to question, the child's ability to use speech and develop language. And so they may ask their pediatrician, or they may ask a teacher in school. And then, or the teacher may be the person who is considering the needs of their child, their student, and how that student can get evaluated for speech and language services. So that's the process that we live in now. The trouble with that process is we miss kids. We miss identifying kids who are in need of services. And at first you're like, well, what's going to happen? How are we going to solve that problem when we don't have enough speech language therapists to begin with to service everybody in need? So what UB sets out to do is to create an artificial intelligence screening tool to assist the speech language therapist in red flagging or identifying children who may need evaluation from the speech language therapist. So what might that look like? And I know that's in development right now. So a lot of these things are being researched and being thought about and brainstormed with speech language therapists from all across the United States. But that might be a tool that is available in classrooms, early childhood classrooms. The AI screener might be a tool that would be available in those classrooms. It could be available in pediatrician offices. It could be available in community centers, libraries, or other entities. The goal is that every child gets screened through an AI screener. And then the AI screener then gives a report or shares information that this particular child needs to be evaluated by a speech language therapist. So right away, we're capturing children earlier in the process to prevent academic concerns in the future. And then the second thing that is so important, as you're seeing here, well, this slide begins to talk about the value of using this screening tool, capturing all of the children and getting them evaluative services as soon as possible. But let's talk about the orchestrator, the artificial intelligence orchestrator that UB is set out to create. I can tell you that this is going to be a tool that is going to actually relieve speech language therapy therapists' paperwork, for example. We believe, and these are just brainstormed ideas, but the ideas currently being talked about is relieving some paperwork responsibilities, capturing progress notes. An AI orchestrator will be collecting video and audio data of group therapy, right, that's being provided in school settings, and then providing that speech language therapist a personalized pathway for each child in that group setting to receive the most research-based, up-to-date interventions that could be implemented in group therapy, while also providing other applications that children can use either during group therapy or outside of group therapy to improve on a personalized level the practices that they're engaged in with the speech language therapist. So imagine that tool is available. It gives the opportunity for speech language therapists to not have to do as much paperwork, for the machine to collect the progress reporting, and maybe down the road help with Medicaid reporting, which we know is a bear for speech language therapists. So it is without a doubt exciting to see this work. Now imagine that these pieces are all in place and a speech language therapist has used the AI screening tool and the AI orchestrator to help manage the work that they're engaged with. It may give more opportunity for these specialists to engage in their work while not having to engage in the paperwork or all of the other digital stressors that are in our lives with Medicaid reporting and so forth, to be able to free people up to use their craft and their skills to impact children and more children in our classrooms throughout the United States. So I think that this is amazing. And I also think that this is the tip of the iceberg, that the work that is being led at UB is going to be change. It's going to change the world within the exceptional education system. So, June, I don't know if I talk too fast, but I hope I got the main points in there, and I'll pass it back off to you.
Thank you, Brian. We are so thankful for you to join our advisory board. And now you can speak up to all of this, better than me. So I will invite you to, for every talk I'm going to be in the future for this topic. Okay, so now Brian gave you this high level, what is our institute is supposed to do, right? And what we plan to do, and to develop AI technology. In the next few slides, I'm going to show you some concrete examples, right? And what technology we are developing, to help the speech language pathologist or the special education teachers. And in Brian's presentation mentioned about the interventions. And this kind of show you, right, intervention is very complex because every child, right, has its own individualized educational targets. And the intervention need to be evidence-based, right? And you need to have the stimulus and materials, and the teachers during the intervention need to find a way to elicit the right kind of behaviors as the skills, right? So that the students can learn. So all of this complexity right now, it has to be handled by the teachers and the special education teachers. And that's why it's very time consuming. And in particular, given an example, right? This is Abby, and she's on our team as well. And she is also a licensed speech language pathologist. And for example, when she's treating the children with speech sound disorders, and she has to look through shelves of the flashcard to find the right flashcards, right? And to help the children. And because every child is the need is different. And so she has to think about, what is the right pair of the flashcard with the right contrastive sound, right? And that can help this particular child. And this is not easy, And for example, sometimes based on the particular child's need, right? For example, they need to learn how to play the sound of M, and she need to find maybe what is the contrastive sound? Maybe the fan, right? Which has a lot of things similar in terms of the length, in terms of the syllables, but they also have some of the property of the sound. They are different because of the way it is. And then to find the right card with the right flashcard, right? So you can do the exercise. And she's kind of challenging us, right? Can we do something, use artificial intelligence to help her so that way she can find the flashcard easier and faster, right? And with all kinds of options, instead of only limited by whatever she has in her bookshelf, and also save her time to look through the bookshelf to find the right kind of the flashcards. And here, just quickly to show you, right? Ideally, you like to show the speech language pathologist, whatever your need are, right? You can pick the sound, you can pick the location of the sound, you can pick the property of the sound. Can we find the right pair of the word, right? And also corresponding pictures. And so she can use. And this is kind of the high level use cases, and it's a need. The rest is taken care of by the computer scientist, right? Can we use artificial intelligence to generate solutions? So give you the high level thinking, right? Like you are as teachers here. Can you simply just type what you need? For example, hey, give me a pair of words, right? With some kind of property in terms of sound. And also give all the conditions, all the constraints. In this case, hey, I found the sound of L at the beginning, for example. We will take care of your need in terms of the text because AI understands the natural language input and go through the complicated computation. And one of technology is ChatGPT like technology, which is the predicting of the next tokens, right? And also have another AI models based on your prediction of the word. For example, if you find it a big or pig, right? Able to, based on the word description, and generate corresponding pictures that is semantically, right, and representing your word, and then show to the SLPs. So the SLP's job becomes much easier, right? Just type and get the right pair of words. And so you can use your do the whatever access you need. And AI will take care of all of this complexity behind the scene. And that is what we are aiming for. And such a system, we already have a prototype. The result I'm showing you here is all generated. So all of this word you are seeing here, all the properties, the pictures, is all identified by the AI, generated by the AI. So now you can see this is a demo. Of course, it's the first stage, but it can already help us SLPs, right? And we also have another tools. If you want to be more explicit instead of only typing, you want to be more kind of explainable. You can also give you this interface. You can pick the phonemes you have, and we can give you the word and explain to you, why this word like a Churchill, right, with all the right sound you need, or you want to have the contrast of sound like a B or P, and what will be the pair of words, and also how many pair of words I can show you. So you can just and also the length, right? You want a 3 letter word or 4 letter word, you can just simply specify it, and we can find the solutions for you. So that is the AI, right? Make your job easier to do. So this is kind of will give you 2 quick examples. So I want to leave some questions here. I don't know if we have time. I'm sorry, this is the first time we run this, and Brian, I kind of probably a little bit run too long, and we probably don't have time. I don't know. Okay, we will have any of this kind of breakout discussions, or just kind of maybe people just can ask questions.
Yeah.
And here's some questions I want to leave for you, right, to think about. What are the daily societal challenges you imagine that AI can help? Please share with us, right? And why do you pick the challenges? And who is going to pay for such a challenge, or should anyone pay for that or not, right? And in particular, how AI can help children with disabilities. Again, similar, what are the challenges children? Maybe you have seen some different challenges. We only give you the speech and the languages as an examples. Maybe there's other type of challenges, and is the current level of investment enough or not? If not, right? And how AI can help, and or what the roles should AI play more broadly, right, in the future for helping our society? AI is not here to take away your job. AI is here to help you to do the job better, right? And so now here you heard of our first talker here. How would you talk about the AI in the future to your friends, to your family members, and to your colleagues, etc.? So I'm going to leave these questions here, and I'm going to turn over this to Christine and to see,
Well, Jinjun,
yeah.
Jinjun, did you see Jeff that gave us a thunderous applause in the chat? Thank you, Jeff. Well done.
Thank you. Yes, I didn't see that one. Yes, I have only one screen here, so I couldn't see it, other things, but thank you.
And Jinjun, I just want to say thanks for not leaving any math questions on this last slide. I appreciate that.
I'll keep my promise. Yeah.
Thank you, Jinjun. Thank you, Brian. This is a really wonderful opening session. Give us a really a nice overview of the AI history and also give this AI Institute as a case to showcase what AI can do. I'm proud to be part of this AI Institute as well. I know we are just coming up to the end of the allocated time. So I don't know if Brian, Junjun would be willing to stay a few more minutes. If anybody really would like to stay a bit longer, if you have burning questions you want to ask, please feel free to type on the chat. Before you go, I do want to mention about next month's session will actually specifically highlighting AI use in special education. So for details, please check out our website and register for that session. We will try to plan the time better, so we will leave more time for discussion, for Q&A, for the future sessions.
Yes, okay, it's our fault. Okay, but we will be here, and probably my fault. Brian is perfect. In terms of timing, I take too much time. I should probably leave the math equations out of this slides.
It was very informative, Christine. Excellent job. This is so smart for UB to lead these conversations on a monthly basis and to help our community have a better understanding of how AI can benefit society and particularly the work of UB. I'm looking forward to the monthly sessions, and I know a lot of our administrators here in Grand Island are also looking forward to it. And we do have Mary Howard. I think you have Mary Howard scheduled in the summer, and she's one of our teachers. She's outstanding, and I think the variety of different presentations throughout the year are really well thought out. So thank you for your leadership in that.
Oh, thank you. Where can we find
and
more information? Upcoming webinar. Oh, okay. So somebody asked a question about. So here is the website. You can find out more about the future sessions. I also want to emphasize we're really thinking the intention for this series is really not necessary as a webinar, like one way to dispense these ideas. So that's why we asked facilitators to suggest some key readings, material, multimedia information for people to view ahead of time. So they could, within the 1 hour, we could have some informative presentation, and then we can open up for discussion specifically about really engage K-12 educator professionals into this space. Because when you think about AI, it feels like, hey, that's all computer scientists work, right? So, but AI is integrating into our daily life and the children's life, students' life. So there's a lot of use cases it's worth exploring. So this is also intended as a space for us to explore some possibilities for collaboration. Right? This AI Institute at UB focus on AI in special education, but I believe Jinju and his colleagues are also interested in other type of education-related real-life problems and solutions. So if any of you interested, this can be a space to explore. But we're hoping we can also carry this kind of conversation discussion beyond those platforms. So we will record all those sessions. We'll share on this website I posted earlier. So if you have colleagues, friends who want to miss the session and would like to watch this recording, you can also check out the website.
Yeah, and I would just add to if anybody is in the education sphere, or who are viewing as educational leaders or teachers, there is a lot that can be done with ChatGPT to support children with exceptional education needs and or children in just general education. So we're doing a lot here to learn more about that, and we have a lot of experiences that would benefit people to learn a little bit more about those things as well. So if anybody just wants to reach out to me or Christine, I'm sure that could be a topic worthy in the future. And I put a funny Synthesia artificial intelligence video as a link in the chat. It's a magic trick that I created using Synthesia AI. So it's more of just a fun thing. So enjoy that as well.
Yeah. And also just want to add here, and because of the time, right, I left the question here, and I do want to get some your thought on those questions, right? And feel free to send us an email offline, and to discuss about it, if you want to set up a time with me. And so I have my email address is just my first name, Jinjing @buffalo.edu, and feel free to send me your thoughts, and if you want to have a chat about those issues. And at UB, we want to work with the community and collect the community's defined challenges, right, use cases, and see how technology can help. So I want to make sure, with UB, right, doing the technology that matters to the community.
Mm-hmm.
Okay, looks like we answered all the questions.
Right. Does anybody have a really quick question, clarification question, or related to Brian and Jinjun's presentation or questions about the series. Okay, we have somebody. Was it Maureen?
Looks like, yeah. Maureen's, you can unmute yourself, maybe? Okay, maybe we are losing people. Maybe Maureen just. Maureen, you are on mute. Maureen, if you raise your hand, you want to ask a question, you still muted. Maybe you need to unmute yourself first. Okay, if a technology issue, also you can just type, and we can see if we can get your question from the chat window. Okay.
Ginger, I was wondering maybe we could stop the sharing so we can return to.
Yep.
Maureen, I don't know if you can hear us. You have your hand up. Do you have a question for us?
Can you hear me?
Yes.
Yep.
Now we can hear you.
Oh, I didn't know I had the mute on. I was wondering, like, in the dissertation, in the higher education, if AI would be better to able to discern between the people who need help in writing skills better, help a little bit better, but also those who are cheaters, they would be using AI to copy work. I wonder how that, if it could be used to that kind of intelligence to find out that those people that are cheaters.
Yeah. Do you want to start, Jinju, and then I can jump in? Or do you want me to?
Yes.
Go ahead, Brian. You have experience. Go ahead.
A little experience. Thank you. Excellent, Maureen. So we have been talking a lot about that here in our school district. And just on a 30,000 foot view, it may require us to work closely on, say, the process of writing. Let's say there's a thesis or a research paper. First and foremost, the process by which children submit sections at a time and demonstrate the writing process and the revision process. It may just look a little different than, say, the traditional, hey, go home and submit it, by November 20th, right? So the process may need to change. Secondly, I would say that whenever we ask children to do work at home, let's pretend ChatGPT doesn't exist, right? Like, let's go back 2 years. When we ask children to do work at home, as teachers in the classroom, how do we know that their work is truly independent of their learning, right?
Yes.
I have 4 beautiful children who are really successful kids, but I can tell you that my daughter, who's in law school at UB right now, when she was in high school, she was using FaceTime to study in front of our fireplace and do all of her homework with her friends. So when she turned that in, my question would be, how do we grade that? Is it really a true representation of Maura's learning, right? So that whole concept of how do we measure learning is super important. And how does that fit into this new world where we can ask ChatGPT to generate a 500-word essay, right? And then what's important next? That the fact that ChatGPT wrote an essay, or that the child completely understands it and can articulate, right, that knowledge that was given to him by Wikipedia, by Google, by ChatGPT, or by some other book, right? So it may just require us to think differently on how we measure learning, particularly when there are tools. By the way, ChatGPT is embedded in Snapchat, right? And I don't know if, Maureen, if you're using Snapchat or not, but the kids are. And so those are the challenges. But I do think that by rethinking the way we measure teaching and learning, it's going to open up a world of authentic performances in classrooms where kids are able to present their understanding of a term paper or an essay or whatever it is. And it may change the way we collect information on the process by which they're writing. So that's just some thoughts. I don't know, Christine, you might have some ideas too.
Yeah, I actually just shared a link in the chat. So this is my colleague at Stanford. They actually study the cheating specifically related to ChatGPT, chatbot, ChatGPT use. So their research basically showing cheating in general in school. Cheating has been around, but has not been significantly increased as a result of ChatGPT, the AI ChatGPT availability. So they actually tracked the usage. So this article actually interviewed those two authors about ChatGPT use in school cheatings. So it seems the concern tend to be overblown. But I think it's important to think about how can we use ChatGPT in a more productive way. So Brian just gave a really wonderful answer to that. How can we, instead of thinking about we try to prevent cheating, why don't we think about more productive way to integrating AI tools for their learning, teach their writing, and providing feedback, individualized feedback, right? Or using AI tool as an editing tool to improve your writing. So there's a lot of ways we can consider the AI tools.
Back in the day, I'd go to Walden Books at the Thruway Mall and buy the Cliff Notes of literature that I was supposed to read in school. I don't know if anybody knows what a Cliff Note is, but they used to sell it at Walden Books. So there's like Christine said, figuring out ways around learning has been around for a long time. So I really appreciate that question.
Okay, thank you.
Jinjun, I wonder if you look at Josh's question about some of the resources related to SLP.
Right. So Josh, I think maybe we should set up a separate meetings, right? Feel free to reach out to me, set up a time, and I'd love to understand it before. Yes, yeah, the 504 is slightly different from the like IEP, but it's also required part of the plans. And yeah, if there's some things you are more specifically looking into, and I'd love to hear more about your use cases, and we can have the conversations maybe separate. Okay.
I just typed your email in the chat, Jinjun.
Yeah. Okay. Yeah. Thank you. Yeah, Josh. Yeah. Let's follow up. Okay. If no more question, maybe so Christine, should we close the line? You know, I know people need to leave for other things, you know.
Yep.
That sounds good.
I do see that there is a question from Josh. It says it's granular, but I have a second grader in Buffalo Public Schools with a 504 plan for speech. So I have to ask, are there any speech therapy specific studies, research, etc., we might look into or get involved with?
Right. So Brian, that's the one I mentioned. Joshua and will email me, and we'll have a separate follow-up conversation. Yeah.
Thank you. Thank you so much.
Yeah. Yeah. Okay.
That sounds good. Thank you so very much, Jinjun and Brian, and thank you everybody for taking the time at the end of the day, attending this exciting PD session. I learned a lot about the AI history from this
I hope you learned about from the math equations too.
I just thought this is simple math for everybody here. Thank you.
All right,
you guys are great.
We look forward for the future sessions. Again, if you are looking for the future session information, and here is the website. And I believe you have to register for each individual sessions. There's no one one registration link for all sessions. All right. Thank you again. Have a good evening, everybody.
Thank you, Christine, for organizing this, and thank you, everyone. Have a good evening.
Thanks.